Article 210.19 specifies that conductors must be sized so that the continuous load does not exceed 80% of the ampacity of the conductor. Article 210.8 states that overcurrent protection devices, or OPs, must be sized to prevent the circuit from carrying a continuous load greater than 80% of the rating of the OCP. The purpose of a load study is to determine the actual electrical load on a circuit or system. The National Electrical Code, or NEC, does not require the use of calculated loads or percentages in load studies. Instead, actual measured load values should be used for calculations. Article 220.11 dictates that the service conductors must be sized to supply the load as determined from Table 220.42. Table 220.42 specifies that the service load is calculated using the actual loads connected to the service. The NEC does not specify a percentage loading limit for services. Therefore, requiring upgrades to every panel based on calculated loads exceeding 80% of the OCP rating is not supported by the NEC for load study purposes. Actual measured load values should be used in load study calculations. The NEC does not specify a percentage loading limit for services, but the service conductors must be sized to supply the actual load. A load study is intended to provide an accurate representation of the actual electrical load on a circuit or system. Using calculated loads or percentages that do not reflect the actual operating conditions can lead to inaccurate results and unnecessary recommendations for upgrades. When conducting a load study, it is essential to differentiate between the requirements for sizing conductors and overcurrent protection versus the methodology for assessing actual loads. The NEC mandates that conductors and overcurrent protection devices must be sized to handle continuous loads without exceeding 80% of their respective ampacities or ratings. This is a safety measure to prevent overheating and potential fire hazards. However, when performing a load study, the primary objective is to determine the true electrical demand of a circuit or system under normal operating conditions. This involves measuring the actual current being drawn by the connected loads over a specific period. The NEC does not require, nor does it encourage, using calculated loads or applying arbitrary percentages when conducting a load study. Doing so can lead to skewed results that do not accurately reflect the real-world electrical demand. This can result in unnecessary and costly upgrades. To accurately assess the load, it is crucial to use appropriate measuring instruments, such as clap-on ammeters or power quality analyzers, to record the actual current flowing through the conductors. The measurement should be taken over a representative period, capturing both peak and average load conditions. Once the data is collected, it can be analyzed to determine the maximum demand, the average demand, and the load factor, which is the ratio of the average load to the peak load. This information is vital for understanding the electrical usage patterns and identifying potential areas for improvement, such as energy efficiency measures or load balancing. When evaluating service loading, it is important to understand that the NEC provides guidelines for sizing service conductors based on the calculated load, which takes into account various factors such as lighting, receptacle outlets, and appliance loads. However, the NEC does not impose a specific percentage loading limit for services. The service conductors must be sized to supply the actual load connected to the service, ensuring that there is sufficient capacity to meet the electrical demand without exceeding the conductor's ampacity. It is important to consider the diversity of the loads connected to the service. Diversity refers to the likelihood that not all loads will be operating at their maximum demand simultaneously. By applying appropriate diversity factors, the calculated load can be reduced to reflect the actual expected demand, preventing oversizing of the service conductors. In summary, while the NEC requires conductors and overcurrent protection devices to be sized based on 80% loading limits to ensure safety, load studies should be conducted using actual measured load values to accurately assess electrical demand. The NEC does not specify a percentage loading limit for services. Instead, the service conductors must be sized to supply the actual connected load, taking into account diversity factors. Understanding these distinctions is crucial for making informed decisions about electrical system upgrades and ensuring both safety and efficiency. Consider a scenario where a panel is protected by a 30 amp breaker. The connected load is consistently measured at 17 amps. According to the firm, you would need to use 24 amps in any load calculation and thus consider upgrading the panel. However, the NEC says you should be using the actual measured 17 amps for the calculation. Now, let's delve into the specifics of performing a load study. The initial step involves identifying the circuits or systems that require evaluation. This may include branch circuits serving lighting and receptacle outlets, dedicated circuits for appliances or equipment, or the main service entrance. Once the circuits are identified, the next step is to gather the necessary equipment for measuring the electrical parameters. A clamp-on ammeter is a versatile tool that can be used to measure the current flowing through a conductor without interrupting the circuit. For a more comprehensive analysis, a power quality analyzer can be employed to measure voltage, current, power factor, and harmonic distortion. Before taking any measurements, it is crucial to ensure that the measuring instruments are properly calibrated and that the user is familiar with their operation and safety procedures. The measurement should be taken under normal operating conditions, with all connected loads running as they would typically. It is important to avoid artificially increasing or decreasing the load during the measurement period, as this would skew the results. The duration of the measurement period should be representative of the typical usage patterns of the circuit or system. For circuits with relatively constant loads, a shorter measurement period may suffice, while circuits with fluctuating loads may require a longer period to capture the full range of demand. During the measurement period, the current readings should be recorded at regular intervals. The frequency of the readings will depend on the nature of the load. For circuits with rapidly changing loads, more frequent readings may be necessary to capture the fluctuations accurately. Once the data has been collected, it can be analyzed to determine various parameters, such as the maximum demand, the average demand, and the load factor. The maximum demand is the highest current reading recorded during the measurement period. This value is critical for determining whether the circuit or system is adequately sized to handle the peak load. The average demand is the average of all the current readings recorded during the measurement period. This value provides an indication of the typical electrical usage of the circuit or system. The load factor is the ratio of the average demand to the maximum demand. This value indicates how efficiently the circuit or system is being utilized. A high load factor indicates that the load is relatively constant, while a low load factor indicates that the load is highly variable. The results of the load study can be used to make informed decisions about electrical system upgrades, energy efficiency measures, and load balancing. If the maximum demand exceeds the ampacity of the conductors or the rating of the overcurrent protection device, an upgrade may be necessary to ensure safety and prevent overheating. Energy efficiency measures can be implemented to reduce the average demand and improve the load factor. This may include replacing old appliances with energy-efficient models, installing occupancy sensors to control lighting, or optimizing the operation of equipment. Load balancing involves redistributing the electrical load across different circuits or systems to prevent overloading any one circuit. This can be achieved by moving loads from heavily loaded circuits to lightly loaded circuits or by installing new circuits to distribute the load more evenly. In addition to the technical aspects of performing a load study, it is also important to consider the financial implications of any recommended upgrades or changes. A cost-benefit analysis should be conducted to determine whether the potential savings in energy costs or the improved reliability of the electrical system justify the cost of the upgrades. It is also important to communicate the results of the load study to the building owner or manager in a clear and concise manner. The report should include a summary of the findings, recommendations for improvements, and a cost-benefit analysis of the proposed changes. By providing this information, the building owner or manager can make informed decisions about how to optimize the electrical system and improve its overall performance. In conclusion, performing a load study is a valuable tool for understanding the electrical demand of a circuit or system and for identifying opportunities for improvement. By using actual measured load values and following the guidelines outlined in the NEC, it is possible to make accurate assessments and implement effective solutions that enhance safety, efficiency, and reliability. Now let's discuss some common misconceptions about load studies. One misconception is that load studies are only necessary for large commercial or industrial facilities. In reality, load studies can be beneficial for any building, regardless of size or occupancy. Even residential buildings can benefit from load studies, especially if there have been changes in electrical usage patterns, such as the addition of new appliances or equipment. Another misconception is that load studies are only necessary when there are known problems with the electrical system. While load studies can be helpful in troubleshooting electrical problems, they can also be used proactively to identify potential issues before they become major problems. By performing regular load studies, it is possible to monitor the performance of the electrical system and detect any signs of degradation or overloading. A third misconception is that load studies are a one-time event. In reality, load studies should be performed periodically to ensure that the electrical system continues to meet the changing needs of the building. As occupancy patterns change, new equipment is added, or energy efficiency measures are implemented, the electrical demand can fluctuate. Regular load studies can help to identify these changes and ensure that the electrical system is adequately sized and configured. It is also important to note that load studies should be performed by qualified professionals who have the necessary expertise and experience. Electrical contractors, engineers, and energy auditors are all qualified to perform load studies. When selecting a professional to perform a load study, it is important to verify their credentials and ensure that they have a thorough understanding of the NEC and other relevant standards. In addition to performing load studies, it is also important to maintain accurate records of the electrical system. This includes documentation of the wiring diagrams, panel schedules, and equipment specifications. Accurate records can be invaluable when troubleshooting electrical problems or planning for future upgrades. By following these best practices, it is possible to ensure that the electrical system is safe, efficient, and reliable. Load studies are a valuable tool for understanding the electrical demand of a building and for identifying opportunities for improvement. By using actual measured load values and working with qualified professionals, it is possible to make informed decisions about electrical system upgrades and ensure that the building's electrical needs are met. Let's move on and talk about some real-world examples. Imagine a small business owner who has been experiencing frequent circuit breaker trips in their office. They suspect that the electrical system is overloaded, but they are not sure where the problem lies. They hire an electrical contractor to perform a load study. The contractor uses a clamp-on ammeter to measure the current on each circuit in the office. They discover that one particular circuit is consistently overloaded due to the combined load of several computers, printers, and other office equipment. The contractor recommends that the business owner install a new circuit to distribute the load more evenly. The business owner follows the contractor's recommendation and installs a new circuit. The circuit breaker trips stop, and the business owner is able to operate their business without interruption. Another example is a homeowner who is planning to install a new central air conditioning system. They are concerned that their existing electrical service may not be adequate to handle the additional load. They hire an electrical engineer to perform a load study. The engineer uses a power quality analyzer to measure the voltage, current, and power factor of the existing electrical service. They determine that the existing service is indeed undersized and that an upgrade is necessary to accommodate the new air conditioning system. The homeowner follows the engineer's recommendation and upgrades their electrical service. The new air conditioning system operates without any problems, and the homeowner is able to enjoy a comfortable home environment. These are just two examples of how load studies can be used to solve real-world electrical problems. By providing accurate information about the electrical demand of a building, load studies can help to identify potential issues, prevent problems, and ensure that the electrical system is safe, efficient, and reliable. It's also important to consider that the NEC is not a design manual. The NEC provides minimum safety standards for electrical installations. It does not provide detailed instructions on how to design an electrical system. It is the responsibility of the electrical designer to ensure that the electrical system is properly designed and installed in accordance with the NEC and other applicable standards. The electrical designer must take into account various factors, such as the type of building, the occupancy of the building, the electrical load, and the environmental conditions. They must also consider the potential for future expansion and the need for energy efficiency. By following these guidelines, the electrical designer can ensure that the electrical system is safe, efficient, and reliable and meets the needs of the building owner. In the context of load calculations and applying demand factors, it's essential to understand their purpose. Demand factors are reduction factors applied to the total connected load to estimate the maximum amount of load that is likely to be drawn at any one time. These factors account for the fact that not all connected loads will operate simultaneously at their maximum rating. Demand factors are typically based on historical data and statistical analysis of similar types of loads. The NEC provides tables of demand factors for various types of occupancies and loads, such as dwelling units, commercial buildings, and industrial facilities. These tables are based on extensive research and are intended to provide a reasonable estimate of the expected maximum demand. When applying demand factors, it is important to understand their limitations. Demand factors are based on averages that may not be accurate for all situations. In some cases, the actual maximum demand may be higher or lower than the value calculated using the demand factors. Therefore, it is important to exercise judgment and consider the specific characteristics of the load when applying demand factors. It is also important to note that demand factors are not intended to be used to reduce the size of the service conductors or overcurrent protection devices below the minimum requirements of the NEC. The service conductors and overcurrent protection devices must be sized to handle the maximum possible load, even if the demand factors suggest that a smaller size would be adequate. The purpose of demand factors is to provide a more accurate estimate of the expected maximum demand for the purpose of designing the electrical system. By using demand factors, it is possible to avoid oversizing the electrical system and wasting money on unnecessary capacity. Understanding the differences between conductor ampacity, overcurrent protection device ratings, and load study measurements is critical in electrical work. Conductor ampacity is the maximum current, in amps, that a conductor can carry continuously without exceeding its temperature rating. Ampacity is determined by factors such as the conductor material, size, insulation type, and installation method. The NEC provides tables of ampacity values for various types of conductors. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The rating of an overcurrent protection device is the maximum current, in amps, that it can carry without tripping or opening. The overcurrent protection device must be sized to protect the conductor that it serves. The NEC provides guidelines for selecting the appropriate size of overcurrent protection device for a given conductor. Load study measurements, as we've discussed, are taken to determine the actual electrical demand of a circuit or system under normal operating conditions. These measurements provide valuable information about the electrical usage patterns and can be used to identify potential problems or opportunities for improvement. When comparing conductor ampacity, overcurrent protection device ratings, and load study measurements, it is important to keep in mind that they serve different purposes. Conductor ampacity determines the maximum current that a conductor can safely carry. Overcurrent protection device ratings protect the conductor and equipment from overloads and short circuits. Load study measurements provide information about the actual electrical demand of the circuit or system. It is important to ensure that all three of these parameters are properly coordinated to ensure the safety and reliability of the electrical system.